Hello everyone, welcome back to the channel. Thanks for coming by. My name is Tim and my channel is Mobang FoYoBucks. On this channel I do a lot of minivan camper building up, all kind of mod I do on the van, but I also do other DIY stuff too. So today I'm going to share with you something interesting. So on my way back from California to Illinois, a 4-day trip, I will try to use my portable power, all power. If you haven't seen that review, I'll put it up here somewhere. And I thought there was an issue with the power station itself, but it turned out to be something else. So let's check it out. So I was using this all power S2000 power station to do my cooking electrically and run my fridge here day and night. However, I had some issue that I wasn't sure whether it's the power station itself or the fridge or something in between, right? So let me explain. So you can see right now the fridge is running. I've been running this for almost 3 hours now. And you can see the minimum voltage for this to run is 11.8 volt. So when it's running, it does have 11.9 volt right now, so that's why it keep running. But if it go below 11.8, it will give you an F1 arrow code and the fridge will stop running. So at first I thought it was something wrong with this power station, which usually is happen when it's dropped below 50%, right? And I never like these type of plug, you know, the contact between, you know, all the negative and positive between this routing and then the pointy head of this plug. And there is other stuff that I'm going to address too about using this type. See, let me show you the sample here. See this? Yeah, this is another issue I'm going to tell you about the next day. But see how the contact is between this tub and these two. So if you put a lot of high current go through this, get hot really quick. This is actually used to charge this power station using the cigarette lighter or the accessory port, but I will address that later on. But I'm gonna address, so it's only happened after 50%, right? So you see when this thing's fully charged, the voltage is a little bit higher than 12.4, so it will compensate for whatever happening in between this connection here. But previous this cable, I have two different connectors instead of just what you look right now. And I will show you the kind of shoddy work I did before on soldering for these connector here. Because I had this and hook up to this and soldering like that. You can see pretty bad job right there. And then it go to this end here. I will show you a picture how bad these connections are, and then I'm going to show you a picture, the new and improved connection I did with these two. So I minimize the connector. Anything in the wire path, you will try to avoid as little cut like this, called connection like this. If you can do a straight line, great, but minimize the amount of it, because that will create a lot of problems along the way. That's why I had issue with this. The fridge will not run once it gets below 50% on the power station. And then whenever I switch this to my in-house battery, it will work because it has a much higher voltage, so it will run because it compensates for whatever issue we have inside of the connection. So if you ever have issue with your fridge, we'll have an F1 arrow. Check the connection, whether the connector go through your fuse box. Chances are the connection is the one that will cause all kind of issue, electrical issue that doesn't deliver enough voltage. Once again, I will show you what a shoddy soldering work will affect the way the current going through these connectors. I did not do a good job at first, but I'm pretty good at it now. So I will show you again the picture of the new connection. So that is a tip for the day. I had a few days of scratching my head and like, what's going on here? Why is my fridge, or is it my new power station cost all this problem? But it's turned out this thing worked great. So you try to use the 12 volt instead. So what I did to compensate for the issue on the road was to use this 120 volt inverter to the fridge, because this would do the same thing, but with the 120 volt it's much more stable. It gives me 14 point something volt to go to the fridge. But if you use the inverter, you lose a lot of power going through that. And I will show you, I was running the fan for about 4 hours, and average is 51 watt per hour, and run for 8 hours. Somehow it drained below 50%. So what give, this is supposed to have 1450 watt hour of power, right? But according to that calculation, I only got maybe 1000 watt out of that if I'm going to use the inverter. So I'm losing what, 80%? Almost, yeah, I'm losing 20% through the inverter. So you try to use the 12 volt or whatever power here without using the inverter if you don't have to. So okay, so they stop now, right? So far, see how the voltage go up to 12.4 volt, which is great. So it's been, this connection, the new improved connection, changed the game. Like I said, check your connection before you dial any of your equipment first. That's the easiest thing to check, and minimize the amount of cut in between the connection. All right, thanks for watching. Next week I'll show you the danger of using this cable and an alternative way of doing this, instead of using the 12 volt plug to charge your power, the high high wattage power station, because this is dangerous, trust me. Bye for now. I'll check you on the next video. Bye for now.